Brought to you by GTA. We start with you.
His whole life, he's been fascinated by the environment and weather patterns that come and go with the seasons. And it's this innate curiosity for Mother Nature's magic and unpredictability that led him to his decades-long career in meteorology. Mark Landers is an assistant professor of meteorology at UOG's Water and Environmental Research Institute of the Western Pacific, or WERI, and co-author of an article that was recently published in the Journal of Coastal Research. The article is based on a master's thesis he worked on in 2011 with then UOG Environmental Studies student Tomoko Bell. Bell's research involved the study of the strontium to calcium ratio of the P. lutea coral species located at Gap Gap Beach. The first groundbreaking event was the result of Bell's need to drill core samples of the coral. Landers explains.
They even invented a new pneumatic drill that could run underwater with a water pump or something, hydraulic pressure.
For this study?
Just for the study. So that was half the effort, was just this machine, and they patented it.
Wow.
Up in Japan.
Having accomplished her goal of collecting samples, the next process was to date the age of the coral, which is similar to counting the rings in a tree, except in a coral one counts the layers, and then analyzing the timestamps for indicators from pollution to sea surface temperatures. Landers was tasked with this job.
At first, I was part of her committee, just overseeing how they were doing the research, and she started to come up with some ideas that the rainfall affected it and how the climate might do it. And at first I wasn't that interested because I couldn't imagine that it would show anything. And I said, let me have a try at it. And then compared it to an ENSO index. And this is where I ran, it was like in the evening, it was 7 or 8 in the evening. I just ran into the boss office and said, John, you're not going to believe this. This coral, it has a climate signal.
Landers' discovery is significant in that the chemical ratio strontium to calcium has an inverted correlation to the sea surface temperature, or SST, meaning that as the SST rises, the chemical ratio decreases. The ratio patterns match the ENSO index, which is the data that shows the weather patterns caused by El Niño, including the SST. What was so surprising to Landers and the other researchers was the fact that the samples were collected in an active and commercial area.
I said, how's drilling coral in Upper Harbor going to come up with anything related to the climate? It's a harbor with pollution and ships and people swimming. In a common sense, most people try to go to these undisturbed, pristine sites where there's no human activity, no possible sources of pollution or power plant waste or whatever.
Landers did say that they collected samples of the same species coral around the island and the results were dramatically different. He's still trying to understand why this is and admits that the coral sample collected at Upper Harbor, although providing amazingly accurate climate signals that are in line with the ENSO index, is a statistical anomaly. He hopes to find answers to these new questions as he continues his research.
Brought to you by GTA. We start with you.